All right, college algebra, we're looking at intermediate value theorem today. In the intermediate value theorem, if you have the function value of a equals like a negative, like -2, and the function value of b is a +4, okay, since this is negative and that's positive, then that means in between those must be 0. So that tells you right there must be a 0 between A and B. Let's look at the graph. I'll show you what I'm talking about. Suppose this is A right here, and suppose here's B. Okay, where these are x values. A and B are x values. Okay, now suppose that the function value of A is -2. So here's -1, here's -2 right here. Okay, and the function value of B is 4. So 1, 2, 3, 4. Here's 4 right there. All right, since this is a polynomial of some kind, these connect, which means there's got to be a 0 here between A and B. There's got to be a 0 there. That's what this intermediate value theorem is saying. So basically all you're doing is something like this right here. You've got this polynomial right here. Okay? This is using the intermediate value theorem to show that this has a real 0 between these numbers, 1 and 2. All right, so I do f of 1. I put 1 in this function right here. So if I put 1 in, 4 times 1 squared would be 4, minus 2 be 2, minus 8 would be -6. So I get -6 when I do f of 1. Now what's f of 2? So I put 2 in. 2 squared is 4, 4 times 4 is 16, minus 4 would be 12, minus 8 would be 4. All right, so that means f of 1 is -6, f of 2 is 4, and then right here, I think this is my answer right here. Since f of 1 and f of 2 are opposite in sign, then there exists at least one 0 between 1 and 2. There's got to be a 0 between 1 and 2. And that's all we're doing. It's real simple. Let's go to this next one here. Okay. Here's my function. A is -6 and B is -5. We want to show that there's a 0 between those. Okay. Now I'm going to get my calculator for this one. All right, so I'm going to type in -6 first. So in parentheses, -6 to the 3rd power plus 4 times -6 squared minus 8 times -6 minus 10. All right, I get -34 when I do that. What do I get when I put -5 in? Well, I'm going to just go back to my equation up here in my calculator. I'm going to go change those 6's to 5's. Okay. Look at that, I get a +5. And these are opposites, which means there's got to be a 0 between -6 and -5. So since -6 and -5 are opposite, A. Look here, this is, since f of -5 is greater than f of -6, not because it's greater, no. It's because they're opposites. And I think that's all we're doing on this. Same kind of thing here. You've got -2, -1, you put it in, and if these are opposites, then there's a 0 between them. Here, we'll do this one. So if I put -2 in here, -2 to the 4th power would be 16, -2 to the 3rd power would be -8 times -4 would be +32. -2 squared would be 4 times it'd be -80 plus 48. All right, so I get 16 plus 32. That's minus A is 16. All right. Now what do I get if I put -1 in there? -1 to the 4th power would be 1 plus 4 minus 20 minus 32 plus 48. So I get 5, negative 52 be negative, what did I say here? Negative 47 plus, I'm getting a 1. I better punch this in the calculator. So I'm making a mistake on one of these. So we'll just go ahead and punch this in. Third power minus 20 times negative 2. You can fast forward through this if you want to. Squared. And negative 56. Yeah, I made a mistake on that one. And then if I go change those to 1s, it's early. So I make mistakes sometimes when it's early. Oh no. I made a mistake on punching this in. Because this right here should be the third power. Okay, I got 1 on this one. That's what I got when I did it in my head. Let's go back up to here. Because I got a mistake here. I don't have third power. Alright, I got negative 48 is what I got there. But now, since these are negatives, a 0 lies between negative 2 and negative 1. Okay, so that's what we're doing. Real simple stuff. That's the intermediate value theorem. If you need any help, give me a holler.